For performing modal analysis on the aeroplane wing, I have opened the Ansys Workbench. In the Ansys Workbench, I am going to go to Analysis Systems. In the Analysis Systems, I am going to select this model and I am going to drag it and place it on the project schematic. So once I have dragged this modal analysis system and placed it on the schematic, now I need to specify the material. So what I am going to do is I am going to go to the engineering data, and once I open the engineering data, right now this particular wing is made up of titanium alloy, and I think this titanium alloy is a material that is already available in the engineering data library. So what I am going to do is I am going to, instead of adding a new material, I am going to go to the engineering data sources, and in the engineering data sources I am going to select the general materials library, and from the general materials library I will scroll up and down to find out this particular material. So here I have found out the titanium alloy. So now what I am going to do is I am going to add it to my present analysis. So I am going to press on this plus button. So if I just press on this plus button, see a book shape has appeared beside this titanium alloy. This represents that this particular material is now available for us for our present analysis. And once I have done this, I am going to close this engineering data. Then I am going to right click on the geometric cell, and then I am going to go to import geometry, then browse, and from the browse I am going to go for say aeroplane wings IGES, and I am going to press open. And once I have imported this particular part file, I am going to just double click on the modal cell in order to open a mechanical. As I have told you, the mechanical is the module in which we are going to perform several types of analysis, such as the structural analysis, transient structural analysis, thermal analysis, modal analysis, even advanced dynamic analysis, electrical analysis, and other sorts of analysis are going to be performed inside Ansys Workbench using the Ansys mechanical module. Now see, once we got this particular model into our Ansys mechanical, now what you need to do is you need to go to the geometry branch and expand this branch and select this particular solid body, and you need to change the material assignment from structural steel to titanium alloy. So once you have changed this one, I am going to generate mesh with the default settings. So I am going to right click and just say generate mesh. So generate mesh, and once I have generated the mesh, now what I am going to do is I am going to go to the models. Now what happens, see, if I go here into the environmental toolbar, what happens, see, lot of types of loads are not present. See, they are not visible. So what it does means is depending on the type of analysis you are going to perform using Ansys mechanical, the availability of different loads and supports will be there. So here in supports you are going to go for fixed support, and you are going to select this particular face and going to say apply. And once you apply, see here it is showing that this particular face has fixed support applied to it. And now we in modal analysis or free vibration analysis, we don't have any loads to apply on the object. We have only the constraints that are to be applied to the object. So I have applied the required constraint. Now what I am going to do is I am going to the solution branch, and I am going to right click on the solution branch. I am going to press solve. So once I click on solve, it is going to find out the natural frequency values and also the mode shape values. So here once the solution is done, in the graphics window, see there are some bars that represent the value of the natural frequency, and there is a tabular data here which shows the mode number and which shows the frequency of vibration. So what it means is in the mode 1 it is going to vibrate at a frequency of 106.23 and the units is in hertz. So what happens, so in the mode number 1 or in the fundamental mode, this wing is going to vibrate at a frequency of 106.23. That means if any working frequency is nearer to this 106.23, what happens, the natural frequency of the wing and that working frequency are going to coincide, and this may lead to the resonance phenomena, which leads to the ultimate failure of this particular wing. Likewise, in the mode 2, it is going to vibrate at 51105 Hz. Likewise, we have found out 6 modes and 6 different frequencies. Now what we need to do is we need to select everything by pressing control, and then what you can do is you can just right click on them and say create mode shape results. So with this, what you can do is, until now you have known what are the different frequencies at which this particular wing is going to vibrate, but by understanding the mode shapes you can predict in which way the vibration will occur at that particular frequency. For that purpose, I have selected this option and I am going to right click on the solution, say evaluate all results. So once I evaluate the all results, see if I click on the total deformation one, so what happens, there are some displacement values that are represented here. So remember one thing, whenever you perform a modal analysis or free vibration analysis, you get some deformation results. This doesn't mean anything. You should not be relying on these values. You should not ignore these particular values. You are only supposed to take care, you are supposed to take these values as the input and this shape as the input. Other than that, whatever the results that is going to be calculated in the model analysis, you will need to ignore. So for now, what I am going to do is I am going to animate the mode shape. See, if I animate the mode shape, what happens? So it is going up and down. From this, what can I understand? If there is a frequency of 106.23, this wing is going to vibrate in the up and down direction, or if we come to the global if we come to the reference of the global coordinate system, it is going to vibrate in the y axis. Then coming to the natural frequency number 2, and I am going to play the animation. See what happens is it is vibrating in the x direction. So what happens is this is one type of mode shape. Then coming to third one, see here what happens, instead of moving up and down or sideways, it is moving in the form of a wave. So what happens if at this particular frequency, this particular type of deformation will occur in the wing. Likewise, you can check for the fourth one. See, this is the twisting torsion mode. So until now we have this is a torsion mode of vibration, and you see here it is a mixed mode of vibration. We can call it as a mixed mode of vibration at fifth mode. Then sixth mode also there is some mixed mode. See here, in addition to this particular translation, it is also having some sort of bending and other sorts of things. So this is how you can perform modal analysis on objects by only applying constraints, and you can find out these frequencies and mode shapes in which the body is going to deform. Then once you have finished this one, what I am going to do is I am going to stop the animation. I can just close this one and I can just save it like file, say save, and I am going to save it as model wing. Sorry, first I need to just browse for the location where I want to save the files, and I will just save wing modal analysis. Okay, so once you have saved it, it will be saved in the default say file format of this Ansys Workbench. You can also save it in the form of an archive by just clicking on file, say archive, and just browse for the location where you want to save the file, and then give the name of the file and you press save. So then it will ask me what are all the things that I need to archive. Then I am going to click these two options as well, and I am going to click on archive. So this is how you can save the Ansys project in the form of a archive file. So this is very easy to send. If you save the file in the archive format, it is very easy to share it with other people. Then in the next lecture, we are going to see how we can perform modal analysis on a Audi car bumper. Thank you.